For problem 20, we're going to start by finding the axis of symmetry. We do that by using the formula negative b over 2a. Now, over here in my equation, I'm going to start by listing what a equals, b equals, and c. So a equals 1, that's the value that's next to the x squared. B is negative 2, and c is negative 1, because in standard form, our quadratic equation is y equals ax squared plus bx plus c. Now, back to finding the axis of symmetry. That is going to be negative b over 2a. Now, the b is already negative, so it's the opposite of b. So the opposite of negative 2 is 2 over 2 times our a value, which is 1. 2 over 2 is 1, and that equals our x value. Now in our vertex, we already know that the x coordinate is going to be 1 because my axis of symmetry is at x equals 1. So I know my x coordinate is 1 because the axis of symmetry goes through the vertex. Then I'm going to find the second point, the y coordinate in the vertex, by putting in a 1 for any value of x in my original equation. So I have y equals 1 squared minus 2 times 1 minus 1. So y equals 1 squared is 1 minus 2, 2 times 1 is 2, minus 1 again. Our 1's cancel, positive 1 minus 1, and we're left with y equals negative 2. So my vertex will be over 1, down 2. Then I know by looking at this that it is going to open upwards because it is a positive 1 for our a value, and that's greater than 0. And when it asks for the point, I know my c value is my y-intercept. So my quadratic is going to cross the y-axis at negative 1. So I can plot this point here. So that is going to be 0, negative 1. And because quadratic equations are symmetrical, I can then also plot the point to negative 1 because I'm going over 1 from that line of symmetry. And then when I go to draw my line, or my parabola, we are not connecting the dots. It is not a line. It is a curve. So it's just a rough sketch, just like that. For problem 23, I'm going to start by listing what my a value, my b value, and my c value are. A is negative 3. B is 0. There is no x to the first power. So b is 0, and our c, which is our constant, is 5. Now I can find my axis of symmetry using the formula x equals negative b over 2a. The opposite of 0 is 0 over 2 times negative 3. So I know the x will equal 0 because 0 divided by negative 6 is 0. So x equals 0. So this is going to go through the origin. Now my vertex will start at 0, will be the x coordinate, and now I need to find the y coordinate. So I'm going to take y equals, and anywhere I see an x in that original equation, I'm going to plug a 0 back in. Negative 3 times 0 squared plus 5. Any number times 0, I know that's just going to be 0 plus 5 equals y, and y is going to equal positive 5. So the vertex will be at the point 0, 5. Now, On the previous problem, we went and found that point using our C value. But in this case, because there's no B, we are going to have to make a T table. And we get to pick our points that we want to plug in. So I'm going to pick the easiest number possible to plug into this equation besides 0. And I'm going to plug in a 1 for x. So over here, my equation, I'm going to have y equals, and I'm going to plug in a 1 for anywhere I see x. So it'll be negative 3 times 1 squared plus 5. Now if y equals negative 3 times 1, because 1 squared is just 1, plus 5, y equals negative 3 times 1 is negative 3 plus 5 to get y equals positive 2. So that will be another point that is on my graph. So over 1, up 2. Again, now we can plot a second point on the other side of the axis of symmetry because we know quadratics are symmetrical across the x-axis and they go and it runs through the vertex. Again, now I'm just drawing a curve. This is not connect the dots. This is not a should not be a straight line. It is more of a curve. So that second point would be 1, 2.